Hey everybody, Mr. Murray here, Mr. Murray's Mathland. Today we're taking a look at solving systems of equations by graphing, the kind of first and most basic way to solve a system. And this right here is a system of two equations with two variables. And when they ask you to solve it, they're really asking you, is there a point that will satisfy both equations at the same time, that will make both equations true? So you're really just seeing, do these two equations have any points in common if we graph them? So we're going to graph these two and see where they intersect. That's really what it's all about. So I'm going to graph this first one in red. Y equals x plus 4. It's already in slope-intercept form for me. So the y-intercept is 4. The slope is positive 1. So that would be up 1 and to the right 1. Or if you run out of room, you want to go the other way, down 1 and to the left 1. Down 1 to the left 1 a few times. And with systems, you want to try to be exact because you're really looking for where two different lines intersect. So don't just do 2 points and draw the line, because unless you draw it perfectly straight, you might be a little bit off, and you really want to see where does it intersect the other line you're about to draw. So I'm going to draw the second line in blue. But as you'll notice, it's not in slope-intercept form, so that's going to be my first thing. I'm going to put it in y equals mx plus b, slope-intercept form. So I want to get the y all by itself, I want to isolate it, so I'm going to move those x's to the other side, subtract, and now you'll have 6y equals negative 4x minus 6. Now I'm going to divide everything by 6 to isolate that y completely. So it's just y equals, and over here, negative 4/6 reduces to negative 2/3 x. Negative 6 divided by positive 6 is negative 1. And of course, just be careful you don't make any silly mistakes dividing, reducing fractions, that sort of thing, because everything depends on these graphs being correct. So our y-intercept is negative 1, and our slope is negative 2/3. So down 2 and to the right 3. And as you can see, as I go to the right, I'm really getting away from the intersection of these two lines, which is going to be up and to the left. So I definitely want to go in that direction. So from my y-intercept, I'll go up 2 and to the left 3, and you can see I land right on that point right there. That's the point they have in common. If you go any further, you're going to be out there. And really, once you know where they intersect, your lines don't have to be super perfect after that, because you're just using the graphs to get to this point right here where they intersect. So our solution is that point, the coordinates of that point, which would be negative 3, 1. Just make sure, of course, to put your x coordinate first, your y coordinate second. And sometimes a textbook or a question may ask you to describe what type of system this is. And if this is a system that has one solution, such as this, one point of intersection, we say that the system is consistent, meaning it has a solution. The lines do intersect. And it's independent because it only has one solution. So those are the terms. Consistent means they do intersect, and independent, think of the word independent, means all alone or one. That means one solution. So they intersect only once. Okay, but the actual solution again is the ordered pair negative 3, 1. Or you could write it separately if you wanted. You could write x equals negative 3, y equals 1. I would accept it that way, and probably most teachers would too. Okay, let's try just another couple here. Now that we know the drill here, I'm going to try to graph these, see where they intersect. First one, already in slope-intercept form. How nice. Y-intercept of 3. Slope of negative 2. So down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1. And as I said, the first line I really like to do just about every point that I can do on the graph, just so it's as graphed as accurately as possible. until I get a sense of where this second line is going to be. And so now I'm going to isolate y here in this. So I want to get y all by itself. So I'm going to add 8x, right? Get those off that side. Now I'm left with negative 4y equals 8x minus 12. I'm going to divide everything by negative 4. And now I'll have y equals 8 divided by negative 4 is negative 2x, and negative 12 divided by negative 4 is positive 3. So now I'm going to graph this line, y equals negative 2x plus 3, and you probably aren't going to go too far here before you realize, hey, wait, it's the same line that I've already graphed. The y-intercept is 3, the slope is negative 2. You're getting the same line twice. So you don't have to literally draw it, right over top of it. It's not as if anybody can see both, unless maybe using colors. So what we say here is that these two lines do intersect, so there is a solution, but they intersect everywhere, at every point. There's an infinite amount of intersection points between these, right? Not just those nice points I've highlighted, but there's an infinite amount of points on a line. So we just say there are infinite solutions. And we say this kind of system is consistent. Remember, consistent just means it has a solution, like they do intersect. But independent meant they intersected only once. So the opposite of independent is dependent. So this kind of system is consistent, they do intersect, and dependent, but they don't intersect just once. They intersect a lot of times. So there we go. And last problem right here. Another two lines. First one already in slope-intercept form. Y-intercept of negative 2, slope of positive 1/3. So up 1 to the right 3, up 1 to the right 3. It'd be right off the graph there. Or down 1 and to the left 3. Okay, next one here, want to isolate that y. So I'm going to subtract 4x from each side of the equation, move those x's over. Now we'll have negative 12y equals negative 4x minus 48. Divide everything by negative 12. And now you'll have y equals negative divided by negative is positive. 4/12 reduces to 1/3 x. Negative 4 divided by negative 12. Negative divided by negative is positive. And 48 divided by 12 is 4. So here is our equation. It is not the same as the one I've already graphed, but it does have one thing in common. It's got a y-intercept of 4, but it's got the same slope of 1/3. So if I start from a different point, a different y-intercept, but I go up and to the right the same amount each time, or down and to the left, you may recall having the same slope, but a different y-intercept means these lines are parallel. They're never going to intersect, even if I were to zoom out on this graph and keep going, right? This and this are never going to touch. There will be no solution to this, since that's, what I'm looking for when I look for a solution is where do they intersect. So this has no intersection, so no solution. Or again, you can use the symbol for no solution, null set. And this type of system, consistent meant they did intersect, and independent and dependent just meant once or more than once. But these don't intersect at all, so we say this kind of system is inconsistent. So that's when you have parallel lines, and that's when you have same slope but different y-intercepts. Okay, so we've just seen one example of each type really from this section, and so hopefully you got a good variety there. If you have any questions, just let me know. Good luck, kids.